Hello, this recording is for ME 575, Materials for Additive Manufacturing. I'll be talking about ionic polymer metal composite materials. The specific material examined in this paper was Equivion, and I am Jacob Schrader. The title of this paper was Searching for a New Ionomer for 3D Printable Ionic Polymer Metal Composites, Equivion as a Candidate. The authors of this paper were Sarah Trabia, Zakai Olson, and Kwong J. Kim. It was published in Smart Matter, Volume 26 in 2017. So the scope of this paper is to compare two materials to be used in the ionic polymer metal composite process. Traditionally, Nafion is the material used in this process. The study proposes to introduce another option for additive manufacturing of ion PCs, and it's called Equivion. So the key questions addressed are to look at a complete material characterization of both Nafion and Equivion, and then go through a performance testing comparing both of the materials as well. So obviously the materials used are a Nafion IMPC and an Equivion IMPC. Again, traditionally the material used in this is Nafion. Equivion is the new material being examined in this paper to see if it is equivalent or better. The process conditions examined are, again, a complete material breakdown and a performance breakdown comparing Equivion and Nafion. And to do this, we first look at the material characteristics. Specifically, we're going to look at the chemical structure, the thermal degradation temperature, and the ion exchange capacity of both, and then go through a performance test looking at the strain of both materials using a batch relaxation test, look at the frequency response of both materials, look at the stress response of both materials using a blocking force test, and look at the mechanoelectric sensing capacity of both materials. So the key result, number one from this study, is the material property comparison. So if you look at the first graph on the left there, you can see it's examining the chemical structures of both Equivion and Nafion. So the critical takeaway from this is that both materials have peaks at 1213, 1153, and 1060 wave numbers, which correlate to a symmetric CF2, an asymmetric CF2, and SO3 chemical compounds. The middle table shows that Equivion has a higher ion exchange capacity compared to Nafion. So the ion exchange capacity of Equivion is 1.25, which is higher than Nafion of 0.98. And then the final plot on the right shows the temperature degradation for both materials. So you can see that they both start to have a high percentage of weight loss at around 300 C, which means that they are comparable for this metric. So both materials are similar in terms of material properties, except for the ion exchange capacity, where Equivion is better. The second result from this study is to do a material performance comparison of Equivion and Nafion. So I'm going to work from left to right on these graphs. The first graph on the left is looking at a strain comparison for both materials. So you can see here that the Equivion samples tested were able to actuate to a higher percent strain than the Nafion samples, and they were able to respond to this strain faster. The second graph from the left shows the frequency response of both Nafion and Equivion. So the Equivion samples have a better and faster frequency response. The third graph from the left looks at the stress response of both Equivion and Nafion materials. So you can see here that Equivion samples were able to absorb a higher stress for all samples tested compared to Nafion, and they were able to absorb a higher stress before relaxing. Finally, we look at the mechanoelectric sensing capability of both materials, and you can see here from the graph on the far right that the Equivion samples perform better in this test compared to Nafion as well. Finally, the key conclusions from this paper are that Equivion is shown to have similar material properties compared to Nafion, except obviously in the ion exchange capacity, where Equivion is greater. And Equivion also performed better in all performance testing compared to Nafion, which allowed these researchers to conclude that Equivion is a viable alternate material for IMPC processing, where Nafion has been the traditional material used. So personal critique for me on this paper is that it's a very detailed analysis explaining all the critical components that must be tested when comparing the viability of a new IPMC material. Also, I would be interested to understand the cost comparison between the both materials, because it's obvious here that Equivion shows superior performance, but Nafion is the more commonly used material. So I'm not sure why this is the case, if Equivion is a new material to the market, or if it is much more expensive, and why people haven't switched to Equivion before now. Thank you. That's all.